Okay, so for this video, we're going to talk about 3 more examples with cross sections. So in the first example, we have y equals x squared, and my x is between 0 and 1. Okay, for the first one, we're going to do it perpendicular to your y-axis, and then it's a quarter circle. And the second part of this question is my sub-intervals are perpendicular to my x-axis, and my rectangles of height equals 3. So the first one, we have perpendicular y-axis. That means this is my y-axis perpendicular. That means I'm integrating with respect to y. In that case, go and draw sides. So we have sides that look like that. Now, we know for a fact that because between 0 and 1, plug in 1, y is equal to 1. That's what we have over there. So first step number 1, we have a diagram drawn. Step number 2, let's draw the cross sections. So in that case, I have a quarter circle. Quarter circle looks like this. That means this is f, this is g. My area is equal to pi r squared divided by 4, since it's a quarter of a circle. Since it's my radius, that means what I have is pi times radius, f minus g squared divided by 4. So my volume for this one is pi over 4 between 0 and 1 of f minus g squared dy. So in that case, we end up with, well, let's go and do this. So that means y is equal, x equals y. This is my f. And then this one here would be x is equal to square root of y. This is my g. Okay? So you have the positive and negative, but because we're going the positive direction of y, it's going to be the positive component. So it means my volume here is going to be pi over 4, 0 to 1. My f is y minus my g, which is square root of y squared dy. So that's number 1. Now, for the second one, we have my cross sections are perpendicular to my x-axis. That means it's going to look like this. So I'm integrating with respect to x. So in this case, we have rectangle of height 3. So let's draw a diagram. F minus g, that's my base, and my height is equal to 3. So my area is equal to base times height divided by 2. Now, just base times height. So that means my base is f minus g. My height here is equal to 3. So that means my volume here is equal to 3 integral from, between 0 and 1. So 0 to 1, and times 3, we have f minus g. So my f in this case, let's go. So this one here, this is my g of x. G of x is equal to x squared. The top function here is f of x is equal to x. So that means it's the top function minus bottom function. So we have x minus x squared dx. And then whatever my value is, that's going to be my answer in this situation. Okay? So that's part number 1. Okay, so example number 2, we have y equals x plus 1 and y equals x squared minus 1. First part, we want perpendicular to my x-axis and the square. Second part, we have y-axis perpendicular to my y-axis and my semicircle. So for this one, it's perpendicular to x-axis. So that means my cross-section is going to look like this. Okay, so that's what it looks like. Okay, so that means just by doing the math, we're going to bounce it between -1 and 2 for this question. So in this case, the first one here, we have a square. So my square looks like this, f and g. So that means my area is equal to f minus g squared, because it's base squared. Okay, so in this case, f in this case is this function, which is the one on top, which is y is equal to x plus 1. So that's my f, and then my bottom function is x squared minus 1. So that's my bottom function. So this one means the top function minus bottom function, you have x plus 1 minus x squared minus 1. Okay, this whole thing squared, so that means my volume is equal to integral from -1 to 2 of x plus 1 minus x squared minus 1, the whole thing squared, dx. Okay. Now next one, I have my function, it's perpendicular, my cross sections are perpendicular to my y-axis. It's a semicircle. So since it's perpendicular to my y-axis, I have a diagram that looks like this. Now, knowing this, I have to integrate with respect to y. So we have this function minus this function. So in that case, we have to write our functions. So let's go ahead and write those. So in that case, x is equal to 1 minus y. The bottom function is x x squared is equal to y plus 1. So in that case, this one is already done. So this one means x is equal to plus and minus the square root of y plus 1. So this is my top function. This part is the positive component because it's a positive, so now square root of y plus 1. And this one here at the bottom here is my bottom function, which is the negative square root of y plus 1. And then because this question had this one and this one, that means for this question you have to break it up into two regions. Okay? So this part here is region 1 and this is region 2. Region 1 encompasses this part of the circle, or parabola, and this one is just this one and that one. So do we want semicircles? So in that case, for semicircle we have f minus g. So that means my area is equal to pi r squared divided by 2. So putting it together, you have pi over 8 and then f minus g squared. So for this question here, r1 is equal to integral from, in this case, from negative 1 all the way to 0. Negative 1 to 0, and I have pi over 8. And I have the top function, which is this one minus this one. So in that case, this minus this is just this minus this, which is adding. So you end up with 2 square root of y plus 1. That's my base. And it's squared in this case, dy. So that's part region number 1. So this part over here. Okay? Now, region number 2, which is this part. Okay, so this is the top function, this is the bottom function, it's still the positive component. So you have pi over 8 between 0 all the way to this point, which is 3. So 0 to 3. So you have square root of y plus 1 minus this function. This function is 1 minus 1. 1 minus 1. So this whole thing is squared dy. So that means my total volume is equal to R1 plus R2. Okay? Now, last but not least, we have example 3. Given there's 3 examples we're going to have to do, 3 parts of this, a equilateral triangle, isosceles triangle with the leg, and then have the trapezoid. Okay? So for this question, I've already drawn out, this is secant, this is tan, and we're doing it perpendicular to x-axis. That means my cross-section is going to look like vertical. Okay, so the first one here, we have equilateral triangle. Okay, so that's f, and this is g. This is 1/2. This means this is root 3 over 2. So that means my area is equal to root 3 over 4, because base times height divided by 2, which is the area. So that means it's f minus g squared. So that means for this question here, my volume is equal to root 3 over 4 integral from negative pi over 3 to pi over 3. Negative pi over 3 to pi over 3. Top function is secant. So secant x minus tan x dx, and this whole thing is squared. Now, part B, we have isosceles triangle with the leg. That means it looks like this, f and g. So this is the base, and the height based on height, which is the same, and divided by 2. So my area here is base times height, which is the same thing, divided by 2. That's my area. So that means this is equal to f minus g squared divided by 2. So my volume here is equal to 1/2 integral from negative pi over 3 to pi over 3 of my f, which is secant x minus tan x dx. Okay? Now, last one here, we have a trapezoid of height 2 and my base 1. Okay, this is my base. The top base is half of base 2. Sorry, this is base 1. Base 2 is half of base 1. So this is base 1. So let's go ahead and draw this out. So that means here we have base 1, base 2. So F and G. Okay, this one is just go with it. Okay, so that means my area here is equal to height divided by 2, B1 plus B2. So my height here is equal to 2. So 2 over 2, my base 1 is F minus G plus F minus G divided by 2. So in that case we have, this one cancels, so you have 3 over 2 F minus G. Okay? So my F here is sine minus cosine, so in that case my area here is equal to my volume, well, my area is equal to 3 over 2 secant minus tangent x. Okay? oh yeah, tan, secant x tan x. That means my volume here is equal to 3 over 2 integral from, same thing, negative pi over 3 to pi over 3, and my top function is sine secant x minus tan x dx. And that concludes our questions, the examples in this case. Okay, so with these, I'm just setting it up. But on a test or any exercise, you have to go ahead and solve for them and find the volume. Okay, so, oh yeah, just to mention, the height is already a unit. So unit times unit, this is already unit squared. So unit squared integral is going to become units to the power of 3, which is volume. Okay, so there goes our example for cross sections. All right, see you in the next one.